Okay, so the do while loop. This loop executes code while a particular condition is being met. Once that condition is met, the loop ends. So if the condition is always being met and it never changes, then that loop will continue infinitely. Now, what I want you to notice is that where you place your code, where you place the while condition, it will affect how the loop actually carries out. So here we have, let's just assume that I equals 12. And let's go ahead and throw that into this loop right here. So we're going to do while I is less than 11. Well, 12 is greater than 11. So as soon as we get to that first line of code, the condition's already met, so the loop gets bypassed. So the result is that I will equal 12. Now let's assume same thing, I equals 12, but look, we've moved our while statement down to the bottom, which means that we have I equals 1, we go to our do, and then I gets entered, so 12 plus 1 equals 13. Now we hit our condition, and we see that, once again, our condition is no longer met, so the loop exits. In this case, because of where we place the while statement, the conditional statement, we end up with a different answer. So if you notice, up here, where we have our while condition at the top, we have an answer that comes out to 12. If we have it at the bottom, it comes out to 13. That's because the code actually ran through the loop on the second part. Okay, we have something similar with the do until loop. Now, this type of loop executes code until a particular condition has been met. And that's key. And if you notice, we actually run into the same thing here with placement of our until condition. Now, again, once that condition has been met, the loop ends. If the condition is never met, then the loop will continue infinitely. So here we're going to assume that I equals 3. Now, if I put it into here, we see do until I equals 3. Our value is already met, our condition is already met, so we bypass the loop. Now again, we're moving this until condition down to the bottom here, and we're going to do the same thing. Assume that I equals 3, and we're going to say I equals 3, I plus 1, that equals 4, and now look what's happened here, is that we will loop until I equals 3. But because we don't meet that condition, right now I equals 4, then it's going to loop back through, and then it's going to equal 5, and equal 6, and 7, and so on. The problem here is that now our condition is never going to be met, meaning that we'll continue adding 1 to the I value. So it's going to continue infinitely, and we are now stuck in an infinite loop. Depending on your variable, like if you have an integer value, it can only hold up to a certain amount. Once it hits that amount, you're going to get an overstack error. So that's unfortunately one way to exit the loop. Otherwise, you might just be stuck in it perpetually. Okay, so that brings us into our for next loop. This is where we have boundary conditions set. So what it is we start off with boundary conditions. We have a lower limit and an upper limit for our boundaries. Once there are no conditional statements, it's just going to run between those boundary conditions that we set. So for instance, if, for example, we have a boundary condition of 1 to 10, then our loop statements will execute the code beginning at 1 and ending at 10. So for instance, let's look at our example here. We start with I equals 1, and we're going to say for x equals 1 to 10. All right, and just ignore this because it's commented out. And what's going to happen is this is actually going to step through. It's going to say 1 plus 1, 2, and then 2 plus 1, 3, and so on until we get to x equals 10. Our end value is going to come out to be 11. So see what's happening here is it's going defaulting stepping by 1. Now if I were to do the same thing, but I were to go ahead and go by step 2, I run through those values again and I get a different answer. So because the default is step by 1, it's going to say 1 plus 1 is going to be 2 and so on, and I come out with a value of 11. But whenever I go ahead and I step through these conditions, this boundary, this range of numbers, if I go by increments of 2, now I'm going to actually come out with a different value of 6. You can actually step negative. So if I wanted to go from a boundary condition of 10 to 1 with a step of -1, that would also work. Okay, what we have here are nested loops. And what that is that's whenever you take one loop and you place it within another loop. Just as any other code, a loop can go within a loop and so can another loop. And what that means is, like if we look here at our example, we have, and we're going to use the variable r and we're going to use the variable c. So for this particular range, the range of r from 1 to 10, and look, I have down here next r, so this right here is one set of loops, or this is a loop, and then within it, this nested loop is for the c range. So we have c from 1 to 10, and we have next c. So if you look right here, we have for each increment of R, we go through the entire range of all the C's. Now, we actually come out with the same exact thing, same exact answer, if you were to actually run the code here and then go to this next one, this nested do until loop, where we have a do until loop here and a do until loop nested within it. If you were to actually run these two pieces of code, they come out with the same answer. So what that tells us is that there's multiple ways to accomplish the same objective with loop functions. Actually, with any code, you can accomplish the same objectives different ways. It's just about how you develop your personal style of coding. So a nested loop is whenever we have a loop that executes another loop within that loop. All right, now what I want to discuss are the common errors of working with loops. The most common error probably is an infinite loop. Loops are set to end whenever a certain condition is met. If that condition is never met, then the loop will continue infinitely or until it's interrupted. And in Visual Basic for applications, the most common way to interrupt a code is by pressing Control-Alt break. The next most common error is an overflow error. This occurs whenever a variable of a certain data type exceeds the limitations of that particular data type. For instance, integer data types have a max range of 32,000 or thereabouts. Should we exceed those values, then we're going to end up with an overflow for that data type. Something similar occurs whenever we have an application-defined or object-defined error. For instance, if we have a loop that works with the number of rows within an Excel spreadsheet, and we exceed the number of rows that are shown within an Excel spreadsheet, then we get an application-defined or object-defined error because we're actually exceeding the max range of that application. Okay, so to review, we have our different types of loops. We have our do while loop. This type of loop execute. We have our different types of loops. We have our do while loop. This type of loop executes code while a particular condition is being met. Then we have our do until loop. This type of loop executes code until a particular condition has been met. Next, we have our for next loop. This loop executes code between a lower and upper boundary. You set the lower boundary and the upper boundary, and it just steps through that, running the code that's in it. The for each loop is similar to the for next, but deals specifically with arrays. Then we went over a step-by-step of how an actual loop works and how it operates. Finally, we went over nested loops, and that's just a way of saying whenever we have a loop within another loop.